Primary cells are the cells which can be used only once. Okay, you cannot use it again and again. Once it is discharged, you have to throw it. Whereas secondary cells are those cells which can be recharged again and again. For example, the cell or battery that you are using in your phone, you can charge it again and again. So you have to tell me which type of battery is there. Okay, that is again a question to you. Now these are the important terms related to cell: EMF of a cell and internal resistance of a cell, and the third one, that is terminal voltage. Whenever you study the cell, these three terms are very important. Now what is EMF? As you can see in this diagram, the first diagram, E is written over here, which represents EMF. Now what is this? This is the voltage when your cell is not connected in the circuit. The voltage which appears at that time across the terminals of the cell, that is known as EMF. Now what is internal resistance of a cell? See, the cell is also made up of some material, and every material offers some resistance. So that is represented with this small r. You can see in first diagram, this small r is basically internal resistance of a cell. Now third one is terminal voltage. Now when you connect a cell in any circuit or any load, as you can see in second diagram, you are connecting a cell across a load having resistance capital R. At that time, whatsoever voltage is appearing across the load, that is basically terminal voltage. And this terminal voltage is less than the EMF of a cell. Now the reason is some of the voltage drop is occurring across internal resistance. Whenever you make any symbol of a cell, we do not make this resistance, this internal resistance. Okay, but we know that there is some resistance which is present in the cell also. The material of the cell is also offering some resistance, that is internal resistance. Grouping of cells. Now cells can be connected in series grouping. Okay, first one, you can see here, positive terminal is connected with the negative terminal of the next cell. So n number of cells can be connected in series in this way. Parallel grouping. When you connect positive on one side and negative on the next side, second side, then m number of cells are shown over here which are connected in parallel. Now why we connect the cells in series and parallel? When we connect the cells in series, voltage increases, adds up. Whereas when current is to be increased, you have to connect the cells in parallel. And when you need both voltage and current to be increased, you can connect them in series as well as parallel grouping. This type of connection is used in railways also, where batteries are used for the supply, to give the supply to the internal lighting and fan circuits. So there voltage and current both are required at a high value, so they are to be connected in series parallel grouping. Now this question I am giving to you, you have to give me the answer. Okay, just solve this question